Okay, so today we are going to do something that says it's solving using 2 steps. That's sort of a misnomer maybe. It may take us more than 2 steps to do it. When they say it's 2-step, it's just implying that we're probably only working with 2 numbers that we need to get rid of. So here is a kind of a sample question that we're working with. Is we're solving for a variable, but now on the same side of the variable, we have 2 numbers that need to be removed. Right? One's a constant, one's a coefficient. On day 1 stuff, everything was either a coefficient or a constant. Now you have both of them. Okay? And the process that we do is the same as we did in day 1. We use opposite operations. Right? If a number is adding to the x, to get rid of it, we're going to have to subtract. Right? So it's always looking at what math operation is it doing to your variable. If it's multiplying to your variable, to get rid of it, you have to divide, or vice versa. Okay? Right? And so the question becomes hey, which number do I tackle first? Right? Do I try to get rid of that 2 first, or do I try to get rid of that 4 first? And in general, most teachers will say, typically when solving equations, we add or subtract first, then multiply or divide, as in the operations we tried to get rid of numbers. So to remember that, try to think of reverse bed mass. Right? Usually with bed mass, we multiply and divide first, then add and subtract, so that we're going the opposite direction. Think about adding and subtracting first, then multiplying and dividing. Okay? So looking at this, right? On the side of the variable, we have the 2 and the 4. By reverse bed mass rules, which number are we trying to get rid of? The 2 first or the 4?
4.
The 4. Because that is subtracting. Right? And to get rid of it, we do the opposite. We add 4. And whatever you do one side, we have to do the other. So we add 4. Okay? Then we clean this up. We go, okay, -4 and +4, they cancel each other out. And on this side, we're just left with a 2w. And the 4s are gone. And what do we have on the right side? 12. 8 plus 4 gives us a 12. Okay, so now we're still working with the left side of the equation here, right? We're not done because we don't have w all by itself. So to get rid of that 2, how do we get rid of it? Divide. Because it's 2 times w, the opposite is to divide. So divide this side by 2, or 1 over 2 if you want to prefer the other way, and divide this side by 2. So the 2's are gone, and you're left with a w. On the other side, we have 12 over 2 as our fraction, which can be simplified. Right? 12 divided by 2, 6. And that is your 2-step equation. Right? You can try to get rid of the constant, then you try to get rid of the coefficient. And that's the procedure that most teachers are going to recommend. Now this is where you get into the fun part of math. Right? This isn't a set rule. Right? When working with equations, oops, that jumped. When working with equations, when we add or subtract, we do that once per side. Right? If you add or subtract to the 4, we do that once per side. And the rule for multiplying and dividing is if you're multiplying or dividing a number to get rid of it, we do that to every single term that you see in the equation. So if you decide to multiply, you're going to multiply everything. If you decide to divide, you divide everything. Okay? By doing it this way, it sort of forces that to happen naturally. But it may not be the most efficient way in certain questions. And I'll prove it to you on this question here. Right? So this time, I'm not going to add or subtract first. I'm going to divide first to get rid of that 2. Okay? And the rule is, to get rid of this 2, I need to divide by 2, just like you did last time. But when we divide or multiply, everything in the equation gets divided. So that gets divided, this gets divided, this gets divided. Okay? So now, the 2 here is gone, and we're left with a W, and a 4 divided by 2 is a 2, equals 8 divided by 2 is a 4. Okay? And we're still working with that side of the equation. Yeah. Now we need to get rid of that 2. How do you get rid of that 2? We add, subtract, multiply, or divide it. What do we do? Right? Add. It's minus 2, so the opposite is add 2. Add 2. So these are canceled out. We're left with 4 plus 2, which is a 6. Same equation, and we should have the same answer. So we just did it 2 different ways. Right? So this is where the fun part of math comes, also the frustrating part of math. Because you guys are going to be working on problems and you go, Mr. Dhaliwal, is this the right first step? Well, there's more than one first step that you can do. My answer is probably going to be yes. Now it really depends on what you do second, if you do that correctly. Okay? And the reason why I show you this is, on this question, yeah, you probably don't want to divide by 2 first, because it makes it harder. But when we get into questions like this, and if you follow that rule of always adding and subtracting first, it can make it more harder than it needs to be. Right? So, for example, right, this fraction here is subtracting the W. Right? If we want to get rid of this number here, we need to, so don't write this down. All right? I'll just do it on the screen, then I'm going to erase everything. We're going to have to add 3 over 2 to this side to cancel this out. And whatever you do to one side, oops, we have to do to the other side. So we're going to add 3 over 2 to this side. Okay? So now, there's nothing wrong with doing this. The hard part is most students struggle with working with fractions. So on the left-hand side, we're left with W over 5. On the right-hand side, we have to do this math. So 1 over 10 plus 3 over 2. You have to combine those two things together. So you have to go back and remember your fraction rules. You need a common denominator. Right? Then we add the tops together, leave the bottoms together. We'll do the same. Then you keep on going on. So if you're comfortable with fractions and you don't see this as being difficult, go ahead, do that. Right? Because that might be faster for you. But what I'm going to teach you now is, hey, if we don't necessarily go in the traditional order, we can make the math a little bit easier for us to do. Right? So what we can do is to solve 2 separate equations that have fractions, right? We can rewrite this entire equation as integers, right? That means whole numbers, right? Plus or minus whole numbers without any of the fractions in there. Okay? And the way we tackle this is we look at the denominators here and we go 5, 2, and 10. What is our common denominator between all those 3 numbers? Right? What's the same multiple between 5, 2, and 10? What would that be? Do I need to hand out the multiplication chart again? Right? What's the common multiple? You look down the 5 table, you look down the 2, 10. Sadie? Sorry? Well, when I say common denominator, what number can all these numbers go into? What number can 5 go into, 2 go into, and 10 go into? They can all go into 10, right? So think about when we're adding fractions, we need to find a common denominator. Same process. They can all go into 10. So to make math a little bit easier in solving this equation, we're going to multiply everything by 10. This term by 10. We're going to multiply this term by 10. And we're going to multiply this term by 10. Okay? And what is this going to do is it's going to get rid of all the denominators. So then we're not working with fractions anymore. Okay? So we compare our top number that we just multiplied to our denominator. We go, how many times can 5 go into 10? 2, right? So 10 divided by 5 leaves us with a 2. So here we're left with a 2w. Okay? Next question. 2 can fit into 10 how many times? 5. 2 goes into 10 5 times. So we're left with a 5 times 3, which is 15, right? With a minus sign in between. Right? So we're subtracting. Then we have the equals. How many times does 10 go into 10? 1. Right? So the 10 and 10 cancel out. Oops, I'm doing green here. That goes into 1. So 1 times 1 is 1. So now instead of dealing with fractions, we have this equation to deal with. It's a much easier one to deal with. Right? And if we follow now the rule of, hey, let's do adding and subtracting first, then multiplying and dividing. Right? On the side, on the variable, what number are we going to get rid of first? The 2 or the 15? 15. Yeah. And it's, what's the opposite of it right now? So it's minus 15. Opposite is? Plus. Plus 15 to this side. And when adding and subtracting, once per side, plus 15. So the 15s on the other side cancel out. We're left with a 2w. What do we have on the right-hand side? 16, yeah. Okay, now what do we do? Divide by 2, yes. Divide by 2 and divide by 2. And now the 2's here cancel out. We're left with a w. And what do we have on the right-hand side? 8. Okay, and that is our answer. So definitely more than 2 steps. But we're trying to move over 2 numbers, and that's what it's sort of referring to. Okay? Now, over here, the same situation can be written in a different format, right? Not everything is always a fraction. So we have a fraction here, and a fraction here, and a 2x. And if you're comfortable with fractions, you can add and subtract this term first, but I think for the most part, people are not comfortable with fractions. So we're going to avoid that. All right? So to avoid it, we look at our denominators. What is our common denominator? We have a 10 on the bottom, we have a 5 on the bottom. What's our common? Jackson? Did you have a hand in there? What would it be for this one? What number can both of these go into? What can both 10 and 5 go into? Sadie? 10. Right? That's the common multiple there. Okay? So we're going to multiply every term. Remember, terms are separated by plus and minus signs by the common denominator. So I'm going to multiply 10 here. That's the first term. The second term is this one. And then the third term over here. Every term gets multiplied by that common denominator. Okay? Now we try to get rid of the fractions where we can. On the first one, there was no fraction here. So we just do this calculation. Right? 10 times 2 is 20. And still have the x. Right? Second term. How many times does 10 go into 10? What do you think, Hennessy? Once. Yeah. Cancel, cancel, goes in once. So 1 times 1 is a 1. And there's a plus sign between these. All right. Next one. How many times does 5 go into 10? Twice. Goes into twice. And 2 times 3 is 6. Okay. So now I'm glad for most of you guys it's clicking in. I was seeing some blank stares, but just to go quickly over it, so minus 1 to get rid of that first, and we get 20x, and the 1s are canceled out, we're left with a 5. And how do we get rid of that 20? Right? Add, subtract, multiply, or divide? Divide. Right? It's always the number on the same side as the x, or whatever your variable is to get rid of it. So now those are gone. You're left with the x. It's 5 over 20. And you use check to see if that can be reduced. Both of them can be divided by 5. 1 over 4. And that's it. Right? So let's do, let's see. Okay. Let's go to the other side here. Okay. Okay. So now let's look at this question here. Okay. Does this look harder or easier than what we did before to you? Harder? Right? In the decimals can make questions look more complicated, but in general, they're going to be easier. Okay? Because you don't have to do any kind of common denominators, you don't have to deal with fractions. Okay? So just treat them as numbers that we are going to calculate on our calculator. So on the side of the variable, we've got two numbers here. We got the 0.6, which is negative, and we have this 0.23. Right? Reverse BEDMAS. Of the two, which one are we going to get rid of first? Right? Yeah, 0.23, because we're going to try to add and subtract first. So to get rid of this, how do we get rid of it? Minus it. So we do that once per side, adding and subtracting. Once per side. That is the rule to keep everything in balance. Okay? So now these cancel each other out. Okay? We're left with x over negative 0.6 on this side. On the other side, we just grab our calculator. Right? And we go, move that off to the side, and we have 1.93 minus 0.23. We get 1.7. Okay. Okay. And then we go back and we look on the same side as the x. There's still a number sitting there. This 0.6. And we got to do the opposite to get rid of it. How do we get rid of it? What? Right? What is that 0.6 doing to the x currently? Is it adding, subtracting, multiplying, or dividing? Dividing. So what's the opposite of dividing? Multiply. So we need to multiply by 0.6. Well, negative 0.6, right? Multiply by negative 0.6. Right? And we're going to multiply by negative 0.6 here, if that helps. All right? I just put brackets around there to help isolate that negative sign. So those 0.6s are gone, and we're left with the x. And on the left side, on the right-hand side, we just need to do that calculation. We just need to go, what is 1.7 times negative 0.6? It's negative 1.02. Right? So if I give you decimals in a question, chances are, even though it looks more complicated, it's going to be easier because you can go just straight to that, add or subtract first, then multiply or divide. So when you have fractions, you have to figure out which path do you want to do first. Right? It may not necessarily be that order. Okay? So, try this one on your own. Right? So on the side of the x, we got two numbers. Reverse BEDMAS. Move it over, use your calculator, figure out what the number is. All right? So which one are you moving first, the 1.6 or the 3.3? 3.3.
You'll be fine.
Seeing you guys get this is awesome. All right? So you subtracted 3.3 just in case anybody I didn't get to talk to. Those got canceled. On the right-hand side, we did that math, and I'm glad that a lot of you guys attempted to do that in your head. When you subtract the two numbers, you get 1.5. Well, negative 1.5. On the other side, we're left with this. Right? And how did you get rid of the 1.6?
You times it.
Times it. 1.6 here, times 1.6 here. Those cancel out. We're left with the x, and we go multiply those two numbers together, and you end up with negative 2.4 as our answer. And we will call it quits there.